Lesson 8.1. It's an introduction to vectors. Now, what is a vector? This term vector here, what it means is it's basically an x and y value, but it's with movement. So like this, for example, in the past, you might have seen something that was 5 units long. Well, what's different with the vectors is this would be saying it's 5 units heading to the right, so it's moving. For example, a car traveling 5 miles an hour east, this arrow would represent that. It would not represent a car going 5 miles an hour to the west, but to the east. That's what a vector is. It has two components, magnitude and direction. Magnitude is how much, direction is obviously the direction is going. So we have an initial point here, the terminal point here. So this would be the initial point. This would be the terminal point. Standard position, that would be in terms of x and y. Now you'll see it in this format here. What symbolizes a vector are these bracket symbols like this. It looks like a less than and greater than. But in the calculator, it's very important to note that we're going to see this as being bracket x, comma, y. That's how it'll look in the calculator. Okay, so we have magnitude and direction. Magnitude is the same thing. It's synonymous with, you're going to see me do a H a lot of the times, or you could have an R for radius. So hypotenuse or radius is the same thing as magnitude. Direction is going to be our theta, and it can go from the north, and it can also go from the x-axis. For the calculator's purposes, it'll go from the x-axis. All right, so with magnitude and direction, we're going to see these in the same brackets, but x and y is going to be congruent to, we'll find out, h, comma, theta. And this angle, when you put the angle in the calculator, it lets the calculator know that you're not giving it an x and y, but you're giving it the hypotenuse and the angle. So we'll use that terminology as well. All right, so we'll talk about a quadrant bearing. That's when it's exactly heading north, east, south, or west. A true bearing means going from north. Parallel, you know, parallel equivalent means they're exactly the same direction, and magnitude opposite would be they're heading against each other. Resultant means they're adding together. Obviously, all these words you can come up with, but that's the key. Rectangular components, I'm going to jump down to here. That is the x, comma, y. That is That is a rectangular components, x and y. Like a standard component or something like that would be magnitude and direction, this form versus this form. All right, so here we go. Vectors, a quantity that has direction as well as magnitude. So again, direction and magnitude. A scalar is something that just can be multiplied times it. So we're going to look at some examples here. We're going to determine whether a hockey puck shot northwest at 60 miles per hour is a vector or scalar. So what determines a vector means it has a magnitude and direction. This one, it says it's 60 miles per hour. That right there is magnitude. Now after this, I'm going to abbreviate and say mag, but that's a magnitude. Not only that, it says it is shot northwest. Well, guess what that is? This is a direction. Since it has magnitude and direction, the correct answer here would be this is a vector quantity. Part B. Tennis ball served 110 miles per hour is a vector or a scalar. Well, what do we have here? 110 miles per hour. This is a magnitude. Does it say which direction? No. Because of that, this is a scalar. It's just magnitude. Part C. Sprinter running 100 meters north. So here we have 100 meters. Pull a coordinate. 100 meters means magnitude. And over here, north would represent a direction. Since we have magnitude and direction, this value is a vector. Now I have one for you to try. See what you can come up with here.